I've repaired that change in the program, and in a minute I'll link the correct program for you, so that when you look at this you'll know what you're doing, or at least you'll know you have the right program. Okay, let's do two like charges. Let's do charge of 1 unit at 40 and 1 unit at negative 40. And we see the symmetry of the situation. The 1 unit charge at each point gives us a nice symmetric distribution, and it'll be symmetric up here. We can see how the field lines tend to repel one another. Okay, the field lines come out here, but as they get close to field lines from the other charge, as field lines from one charge get close to those from the other, they tend to repel a bit. And we see that repulsion right here in the center. We also see that the field lines are closer together here in the center, indicating a stronger electric field in the center than out here. However, we do see that the field lines, as we move away, tend to get more and more evenly distributed. In here, they're much stronger in the middle than they are out here. And down here, they're still closer, but not quite as much. As a matter of fact, if we take the same charges but put them closer together, we can see what happens at a greater distance. Okay, let's say we take a charge 1 and put it at negative 1, 0, and a charge of 1 and put it at 1, 0. Now this amounts to simply zooming in on the distribution of the charges, and we see that the spacing of the field lines along this circle is more uniform than it was. We can take this a little bit further. We can put a charge of 1 at 0.10 and a charge of 1 at negative 0.10. And now we see there's no tendency for the charges for the field lines to be closer at one point than at another. Now where the field lines tend to double up a little bit, that's simply a coincidence of the way the angles are chosen and the way things are plotted here. But if you count the number of field lines from here to here, and then from here to here, from here to here, and from here to here, they come out just about equal out here. Now what we've essentially done is, by putting the charges closer together, we've zoomed out. We've zoomed away from the charges, and we can see more clearly what happens. What if the charges are unequal? Let's do another one. Let's do a charge of 10 at negative 40 and 1 at 40. These are like charges. Field lines will tend to repel one another. But you see, we don't have as many field lines over here as we do over here. The field is a lot less strong on this side than it is on this side. This is due to the fact that we have a strong charge here fighting a weaker charge here in this area. If we zoom out on this charge, let's see, we have a charge of 10. Let's put it at, now, let's say 0.5. Let's go to negative 0.5, 0. And a charge 2 of 1 at 0.50. Actually, seems to be another glitch in the program because it should put more field lines out here. Not sure how that's happening. We'll have to fix it.